Algebra 2 Notes 6.8 Graphing Radical Functions. Graph the parent functions given. Go ahead and pause the video and see if you can graph y equals x, y equals x squared, and y equals the absolute value of x. All right, y equals x should be just intercept at 0, rise 1, run 1. Quadratic is that parabola. And then absolute value, we just want all those y's to be positive. So it's similar to the first graph, but just this part that goes down below the y-axis, we're just going to flip it back up. Makes that V shape. All right, the new one we have today is square root function. Okay, we're going to look at the cube root function, but we're primarily going to focus on the square root function. All right, so what is the square root function? Well, it's the inverse, you guys found, of y equals x squared. So if we think of some points, they'll give us like nice numbers here. We could plug in 0 because the square root of 0 is just 0. We could plug in 1. What is the square root of 1? That's just 1. Okay, next number we might want to plug in is maybe like a 4. You could plug in 2 and 3, but they're not going to give you nice numbers. So if I plug in 4, square root of 4 is 2. And then 9, square root of 9 would be 3. So let's go ahead and plot these points. So we have 0, 0. We have 1, 1, 4, 2. So it's just that parabola. The only thing is it's only the top half. Okay? To get the bottom half, we would have to have also y equals negative square root of x. And then that would include these points. So if you remember from the inverses, we're getting plus or minus. That's where the minus came into play. Okay, what is the domain of the square root function? So if you go left to right, what can x be? So we can't plug in a negative 1 and get a real number. So we say domain x must be greater than or equal to 0. And actually the range would be y also needs to be greater than or equal to 0. So if you can find that starting point, that's where the domain and range start from. All right, the cube root function is similar. So let's plug in some numbers here. So again, we can choose 0. The cube root of 0 is 0. 1, the cube root of 1. What times what times what is 1? And then maybe do like 8. What is the cube root of 8? Be 2, right? Okay, so we can plot some points. Oh, now this one, you can plug in negatives. Negative 1, what times what is negative 1? Cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. Okay, so then connect the dots. So if you've graphed y equals x cubed, it's just the inverse of that one. Okay, this time the domain, as I go left to right, what can x be? So as I'm moving left to right, x can be any number. Okay, so we can say all real numbers, all reals. Oops, all reals. All right, so now what we're going to do is use those transformations that we've been doing with all of our other graphs. So here's the general form of the radical function. So A, that's your vertical stretch or shrink. Also, if that number is negative, remember, it'll flip upside down. H, that's going to be your horizontal translation. And again, since it had minus h, we need to move it the opposite direction, left or right. Left or right. Okay, and then K, that's your vertical translation. So that's how much your function will move up and down. All right, so let's practice a couple of these. State the transformations that occur in each equation. Okay, so this one, we're adding 2 after the equation. So that's the one that's going to move up 2. Okay, so if you had your original square root function, if I moved it up 2, my starting point is now 0, 2. And it'll look something like that. All right, I'll do number 6 here. So this one has a couple things going on. One thing, we've got this negative out here. So we're going to say reflect across the x-axis. Next, the 3 on the inside. Remember, this goes opposite direction. So move 3 to the left. And then finally, the 4 at the end is how much you're going to move down. Okay, so why don't you guys pause the video and try numbers 2 through 5. Okay, go ahead and check 2 through 5, and then we'll look at a graph. All right, so number 1, if we want to graph this, I like to first think of that translation. So we see this -2, I'm thinking down 2. Okay, I do want these to be precise. So you might want to sketch out what the original one would look like, which is 0, 0, 1, 1. We've got 4, 2, 9, 3. So then if I want to move down 2, we're just going to take every point and move it down 2. You could also think of your new starting spot as the opposite of the sign in parentheses, which is 0. Same as the sign on the outside. 0, -2 is where my square root function is going to start. Okay, so something like that. All right, number 2, this one has a vertical stretch and 4 to the left. So vertical stretch of 2, and then 4 units to the left. So again, if you think of that original graph, that kind of helps visualize what's going to happen with this transform graph. So vertical stretch of 2. So what that's doing is it's taking each point and doubling it. So 0 doubled is still 0. 1 doubled would be 2. 2 doubled would be 4. 3 doubled would be 6. Okay, so now we want to move all these points 4 units to the left. 1, 2, 3, 4. There's my starting point. Or again, you can think what's your starting point, -4, 0, and then do the square root function, but we have to double the answer. So like square root of 1 is 1, but doubled would be 2. Square root of 4 is 2, doubled would be 4. Same thing as the green point, move 4 to the left. Okay, square root of 9 is 3. Doubled is going to be up to 6. Okay, so then that's going to be your new graph. On the assignment, it asks you to find domain and range, so let's practice that real quick. So domain, what can x be? So again, look at this graph and think, when does x start? So x isn't started yet until we get to this point. Okay, so x needs to be greater than or equal to -4. And then what about your range? What's your y value going to be? So think, what's the lowest part of your graph? And then y needs to be greater than or equal to 0 in this case. All right, let's look at number 5. That one has that negative out in front. Remember, that was the reflection across the x-axis. But what does that look like? So if I have my original graph, sometimes it just helps to make that original graph. So square root of 4 was 2 and square root of 9 is 3. I want to flip those over the x-axis. Well, 0 flipped is still at 0. So instead of going up 1, we're going to go down 1. So this is kind of the other half of the parabola. Okay, but that's going to be the only part that's in your answer. So this time for domain and range, domain still is the same. X needs to be greater than or equal to 0. But range, what can y be? So now we have a maximum point, not a minimum point. So we're going to say y needs to be less than or equal to 0 because it needs to be 0 or below. All right, why don't you guys pause the video and go ahead and try 3, 4, and 6. All right, number 3, it should be 3 to the left and up 1. Number 4, 2 to the right and down 4. And number 6, you've got that vertical stretch of 2 and then down 4. So go ahead and get started with the worksheet assignment and submit it on Canvas.